Hello and welcome to another video on differentiation rules. In this video, we are going to talk about derivatives of trigonometric functions. Before we start the derivative, we'll just look at two special limits that we have for two trigonometric functions. The first one that we have here is limit as x approaches 0 of sine x over x equals 1. And then if you remember, we talked about this one at the beginning. We made a table and we actually proved this one. There's a geometric proof in the book. If you want to see the proof of this uh, limits, it's in the book. We are not going to do the proof, but we are going to use it here. Okay. And then another limit that we are going to use is limit as x approaches 0 of cosine x minus 1 over x equals 0. So these two limits we are going to use here. So let's look at this limit example first. So for the first one, we are going to still use this formula. So limit as x approaches 0 of sine x over x equals 1. Now here, we don't have exactly the same thing that we have here because we have 3x and we have x in the bottom. So just to make it same, if we have x here, we need x here. So we have 3x here, so we'll make the bottom one, the denominator, also a 3x, okay? So what we do is we'll multiply by 3 on both numerator and denominator. So when we do that, we get limit as x approaches 0, 3 times sine 3x over 3x. Now these 3 we can factor it out because it's a constant, so we can write 3 limit as x approaches 0 sine of 3x over 3x. Now let's do this. Let's do a substitution here. Let 3x equals theta. Now the limit we have is x approaches 0. Now as x approaches 0, since theta is 3 times x, that means theta also approaches 0. Now we can write this as 3, okay, then limit theta approaches 0 of sine theta over theta. So now we have exactly what we have here. Limit as x approaches 0, sine x over x equals 1. So we have exact same thing here. So that means this limit right here, this limit is 1. So we have 3 times 1, which is 3. Now let's look at the second one. For this one, we will use both of these. Okay, we'll use this one and the other one, which is limit as x approaches 0 of cosine x minus 1 over x equals 0. Okay, now in order to get this one, if we divide both numerator and denominator by x, or if we multiply both numerator and denominator by 1 over x, this limit becomes limit as x approaches 0 cosine x minus 1 over x divided by sine x over x. So this is multiplying numerator by 1 over x and denominator by 1 over x, okay? Now what we can do is by limit law, we can say limit as x approaches 0 cosine x minus 1 over x divided by limit as x approaches 0 sine x over x. Now we know that this limit in the numerator, this limit equals 0, divided by the limit in the denominator equals 1, and 0 divided by 1 is 0. So this is the limit. Now we are going to look at the derivative of trigonometric functions. So we have this basic 6 trigonometric functions here. So we have sine x, here sine x, the derivative of sine x is cosine x. Then we have cosecant x, the derivative of cosecant x is negative cosecant x. Cotangent x, derivative of cosine x is negative sine x, and so on. So we have all 6 of them here. We'll prove one of this formula, okay? And then similarly, we can prove the other one, and I'll talk about that. So first, let's just take the first one and let's prove this. Okay, so let's go ahead and prove the derivative of sine x is cosine x. In order to do that, what we need to use is we have to use the definition of derivative. So the derivative of function f of x denoted by f prime of x equals limit h approaches 0 f of x plus h minus f of x over h. So this is the definition of derivative. Now here our function is f of x equals sine x. So that is the function that we are finding derivative of. So by the definition of the derivative, okay, so let's go ahead and prove that. Let's write the proof. So by the definition of derivative, the derivative of f of x equals sine x is f prime of x equals limit h approaches 0. Now f of x plus h means sine of x plus h minus f of x means sine of x divided by h. So in the numerator, let's go ahead and use one of the trigonometric identity or the sum formula. So this one sine x plus h. So we know this formula from trigonometric. So sine a plus b equals sine a cosine b minus, sorry, plus cosine a sine b. Okay, so that's what we are going to use here. So this equals limit as h approaches 0, so that is sine a means sine x cosine h plus cosine x sine h minus sine x, which is this second term here, divided by h. Now we have sine x here and sine x here, so let's put them together so that we can factor something out. So that equals limit h approaches 0 of sine x cosine h minus sine x. So I put this one right here with this, okay? Then let's split this fraction as well and write over h, and then plus, let's distribute that limit, and then write cosine x sine h over h. Now from here, we can factor out sine x, and we can factor that out and put it outside of the limit because the limit is h approaches 0. So we can factor sine x outside of that limit. Okay, so we can write it here, sine of x, then limit h approaches 0 cosine h minus 1 over h. Plus, similarly, we can put that cosine x outside because the limit is h approaches 0, so x is not going to affect that. So that gives us limit h approaches 0 sine h over h. Now, if we use the special limit that we just talked about, okay, so this limit right here is 0. So that means, and then this limit right here, this is 1. So that means this equals sine x times 0 plus cosine x times 1. And that gives us cosine x. So f prime of x equals cosine x, which means the derivative of sine of x, the derivative of function sine x equals cosine x. Okay. Now, following exactly same process, we can prove that the derivative of cosine x is negative sine x. And then to prove for cosecant, we can just use the quotient rule. Okay, so cosecant is 1 over sine x, and then if we use the quotient rule, we'll get the derivative for cosecant x. Okay, similarly, once we know the cosine, the derivative of cosine, we can find for secant x using the quotient rule again. Tangent is sine over cosine. Using the quotient rule, we can find it. So we can find for all of them once we know for sine and cosine. For sine, this is how we prove it. For cosine, we do exact same thing, okay? And then we can prove that, okay? So now let's go ahead and use them to find derivative of some functions involving trig functions. So the first example here is y equals e to the 3x times sine x, and we are finding the derivative. Look over here, we have a product of two functions. So we have e to the 3x as one of the functions, and then sine x as the other function. So we have to use the product rule here, okay? So dy over dx equals, now the product rule, if you remember, so we have first function and second function. So the derivative is first function times derivative of second plus second function times derivative of first. So here the first function is e to the 3x. So first function times derivative of second. So derivative of sine x is cosine x plus second function, which is sine x, times derivative of first function, which is 3e to the 3x. And then we can factor out e to the 3x from both the terms. So we get dy over dx equals e to the 3x, and then we have cosine x plus 3 sine x, and then we can just leave it right here. So this is the derivative. Now let's look at the next example that we have here. Again, let's go ahead and find the derivative. So dy over dx equals, so derivative of cosine x is negative sine x minus, here we have product of two functions. So we have to use the product rule. So the first function times derivative of second function, so derivative of sine x is cosine x, plus second function, which is sine x, times derivative of first, which is 1, because the derivative of x is 1. And this equals negative sine x minus x cosine x minus sine x. And then we can combine negative sine x and negative sine x. So dy over dx equals negative 2 sine x minus x cosine x. Let's look at this function here. Here we have cosine x over 2 plus sine x, so we are going to use the quotient rule. So remember the quotient rule, we have the numerator over denominator. So if we are finding the derivative, so it is denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared. Okay, so now dy over dx equals, so the denominator is 2 plus sine x times derivative of numerator, so derivative of cosine x is negative sine x minus numerator, which is cosine x, times derivative of denominator, so derivative of 2 is 0, derivative of sine x is cosine x. Then everything divided by 2 plus sine x, the quantity squared. Now dy over dx equals, so if we distribute this, if we multiply this, we get negative 2 sine x minus sine squared x minus cosine squared x divided by 2 plus sine x, the quantity squared. Now dy over dx equals, so we have negative 2 sine x, and then if we factor out negative 1 here, okay, so we get sine squared x plus cosine squared x, everything divided by 2 plus sine x, quantity squared. Now dy over dx equals negative 2 sine x. Now we know that sine squared x plus cosine squared x is 1, so negative 1 times 1 is negative 1 divided by 2 plus sine x, the quantity squared. I think we cannot simplify further than this, so we'll just leave it right here. Now this one is find the equation of the tangent line to the curve y equals 2 cosine x at pi over 3 comma 1. So first we need to find the slope of the tangent line. The slope of the tangent line is given by the derivative of this function. Okay, so let's go ahead and find the derivative of this function first. So we have dy over dx equals, so this is just 2 constant times the derivative of cosine x is negative sine x. So that becomes minus 2 sine x. So that's the derivative. Now the slope of the tangent line is given by the derivative evaluated at x equals pi over 3. Okay, so the slope of the tangent line is given by dy over dx at x equals pi over 3, which is negative 2 sine pi over 3. And we know that sine pi over 3 is square root of 3 over 2. So we have negative 2 times the square root of 3 over 2, and that gives us negative square root of 3. So that is the slope. Now we have a point, we have a slope, so we'll go ahead and find the equation of the tangent line. So the equation of the tangent line is given by, okay, y minus y1 means 1 equals m is the slope, which is negative square root of 3. So m times x minus x1 is pi over 3. So if we distribute that square root of 3, we get, so y minus 1 equals negative square root of 3 times x plus square root of 3 pi over 3. Okay, and then if we add 1 on both sides, so we get y equals negative square root of 3x plus, let's write pi here, so pi square root of 3 over 3 plus 1 when you add 1 on both sides. So we'll not put this into the calculator and write decimal, we'll just leave it as it is because we want the exact answer, okay? So we don't want to approximate anything here. Now next example is find the derivative of this function. Here we have to use the quotient rule. So let's go ahead and find the derivative. So dy over dx equals, now the quotient rule is denominator, which is 1 plus secant x times the derivative of numerator. So derivative of tangent x is secant squared x, then minus numerator, which is tangent x, times derivative of denominator. So derivative of 1 is 0, derivative of secant x is secant x tangent x, then divided by 1 plus secant x squared. So this gives us dy over dx equals, now if you multiply here, if you distribute this, so you get secant squared x plus secant cube x minus, so this is tangent squared x, secant x, everything divided by 1 plus secant x squared. Now, in the numerator, we have secant x in all the terms, so let's factor that out. So dy over dx equals, if we factor secant x out, then we get secant x plus secant squared x minus tangent squared x divided by 1 plus secant x squared. Now from trigonometry, you know this identity, so we know that 1 plus tangent squared x equals secant squared x. So if we subtract tangent, and we get 1 equals secant squared x minus tangent squared x. So secant squared x minus tangent squared x is just 1. So from here we get dy over dx equals secant x times secant x. So this is 1. So plus 1 divided by 1 plus secant x squared. Now we have a common factor in the numerator and denominator. So we have 1 plus secant x in the numerator, and we have 1 plus secant x squared in the denominator. So that means this one and one of these factor will cancel out. That means our derivative dy over dx equals secant x over 1 plus secant x. And then we'll just leave it right here. Now this is try now example question. So I want you to pause the video, try that example, and then you can resume the video and check your work, okay? Let's go ahead and do that. So y equals secant x, so that means dy over dx equals, so the derivative of secant x is secant x times tangent x. So we got the first derivative. We are asked to find the second derivative. That means we'll go ahead and differentiate again. So when we differentiate again, so we get d2y over dx2 equals, so we have to use the product rule here because we have secant x times tangent x, so two different functions. So the product rule is first function, which is secant x, times derivative of second function. So derivative of tangent x is secant squared x plus second function, which is tangent x, times the derivative of first function, which is secant x times tangent x. Now let's go ahead and multiply this and let's see what we get, okay? So d2y over dx2 equals, so this is secant cube x plus secant x times tangent squared x. Now if you factor out secant x, you get secant squared plus tangent squared, but that's not really going to help us to simplify further. So what we do is we'll just leave this one right here, okay? That's all for this video. I'll come up with another video. In the next video, we are going to discuss about other differentiation rules. Yeah, we'll just stop here for this video.